A common RAG optimization quietly made retrieval worse. Here's the experiment. Imagine a customer support engineer searching her company's docs. What's the cancellation policy for product SKU1042? Last episode we got that one right. The reranker, that strict editor, pushed the matching FAQ to the top. The customer got the answer. Win. But here's what we didn't show you. The chunk that one contained the words, "Annual refunds are not available." That sentence was right. It was also alone. The vector that found it was built from those 6 words and nothing else. The chunk didn't know it belonged to SKU1042. It didn't know the heading above it. It didn't know which book it was even from. Every chunk has amnesia. Here's the order we've used since the start. Read the document, cut it into chunks, embed each chunk on its own, store the vector. The embedder sees 100 characters and produces a number. It doesn't know what came before. It doesn't know what came after. It doesn't know the title, the section, the product code. The chunk is alone with its words. It's not broken. It's how every retrieval system on the planet works. It just has this one quiet problem. Take that one chunk again. Annual refunds are not available. Embed it in isolation. What does it know about? Refunds, generally. Annual subscriptions, generically. It doesn't know it belongs to a specific product's cancellation terms. The chunk has the right words. It just lost the right context. So here's the hypothesis. If we could give the chunk back its context, embed it together with the document around it, retrieval should improve. The chunk would carry the heading, the surrounding terms, the document's voice. Same words, more memory. That's the idea. Now we test it. Late chunking is the test. 2 words. Flip first, embed second. Take the long context reader, an embedder that can read up to 8,000 tokens in one pass, and let it read as a whole document. While it reads, it builds a contextual representation of every word, knowing every other word. Then, only after the whole document has been understood, we cut. We pull the parts of the representation that fall inside each chunk into a single chunk vector. Early chunking cuts first, then understands. Late chunking understands first, then cuts. That sounds like an upgrade. Cleanest version of the experiment. Same 5 books we've been searching for the last 3 episodes. Same way of cutting them, by chapter heading. Same chunk boundaries. Same reranker. Same prompt. The only thing we change is when the embedder reads. 3 pipelines. The simplest baseline, fixed size chunks embedded alone. The chapter heading pipeline, same chapters embedded alone. And the late chunking pipeline, same chapters embedded with the whole document around them. 3 pipelines, 1 question, same shelves, let the numbers speak. The question we asked last episode, what's the cancellation policy for SKU1042? 3 pipelines run it. The reranker, our strict editor, reads the top 20 results from each and picks the top 3. Whatever it picks is what the language model sees. Whatever it picks is what we measure. 3 answers, 1 number per pipeline. Look at the scoreboard. The simplest baseline, fixed size chunks, embedded alone, perfect, 3 of 3. The chapter heading pipeline, embedded alone, also perfect, 3 of 3. Late chunking, same chapters, embedded with the whole book around them, 2 of 3. Late chunking lost. The technique that was supposed to give chunks document memory made retrieval worse on this question. We expected an upgrade. We got a regression. That's data we have to take seriously. Why? Look at what late chunking ranked first before the reranker stepped in. Not the matching FAQ, not the cancellation paragraph. The document's title, Illuminflow B2B Software Catalog. Here's what happens. When the embedder reads the whole book before cutting, every chunk inherits a flavor of the whole book. Repeated terms near the top of the document, the catalog name, the brand, the section labels. Pull every chunk's vector slightly toward themselves. The chunk that said, annual refunds are not available, now smells like a product catalog instead of a cancellation policy. It's still semantically right. It's just outvoted by everything around it. The chunk gained document memory and forgot itself. And here's the real lesson. Last episode, Chapter. Heading chunking already solved the context problem the cleaner way. Every chunk already carried its heading. Late chunking added document context the chunk didn't actually need. The tool was solving the wrong failure mode. 2 things to take away. 1. When chunks already carry their own context, late chunking can dilute more than it adds. It helps short, context-poor chunks. It hurts context-rich ones. Match the technique to your chunks. 2. Even when the dense reader works, it works on as meaning. It doesn't work on words. Ask it for audit log retention, a precise hyphenated term, and it will smooth across the surface form and miss the exact match. Product codes, ticket numbers, method names. 2 different failure modes, same fix. The keyword reader finds words. The dense reader finds meaning. Next episode we let them vote. See you in the next episode.